Okay, now for what we have in the case of number 16. Again, we have a is equal to dv over dt. And separating the differentials. And given that a is going to be the reciprocal of the square root of t plus 4, so we're going to have dv is equal to 1 over the square root of t plus 4 dt, and integrating over both sides. So the antiderivative of dv, of course, is v itself. Antiderivative of the reciprocal of the square root of t plus 4 is going to end up at 2 times the square root of t plus 4 and we have plus c1 with the initial velocity equal to -1. And the -1 is equal to 2 times the square root of 4 plus c1. Square root of 4 is 2. 2 times 2 is 4. Take away from -1, so we have c1 is equal to -5. So we have, in more specific terms, so we have for v, that is going to be equal to 2 times the square root of t plus 4 followed by the subtraction of 5. And carrying over to what we have concerning distance. Again, so we have for v itself, again, we have 2 times the square root of t plus 4 minus 5. And if we go ahead and separate the differentials, the dx is equal to, again, the quantity of 2 times the square root of t plus 4 minus 5 dt, and integrating over both sides. Now we have the x is going to be equal to, now the antiderivative of 2 times the square root of t plus 4, that is going to end up at 4/3 of the quantity of t plus 4 to the 3/2. Next antiderivative term, we have -5t, and of course we have followed by the next constant, which we're going to determine on the basis that x naught is equal to 1. Whenever t is equal to 0, so we have 1 is equal to 4/3. And what is going to be 4 to the 3/2? Minus 5 times 0 plus c2. 4 to the 3/2 is 8 times 4/3 is 32/3. Take away from 1, so we have for the value of c2, this is going to be a negative non-integer value, which we will have at -29/3. So we have for the solution of the distance at any time t, we have the x of t is equal to 4/3 times the quantity of t plus 4 to the 3/2 minus 5t minus 29/3.